Hi, Integrated Math 1. Welcome to lesson 2.4.3a, module 2, topic 4, lesson 3. And we've broken it up over 2 days to make it a little easier to manage, which means today we're just going to do activities 3.1 and 3.2, starting on page M2-289. Now, we have already been doing perimeter and area, rectangles and triangles, no big deal. But what happens when we get weirder shapes? We can still manage it. We're smart, we are wise, we are good. So let's do this thing. Let's start off just by finding the perimeter of a parallelogram. So the pattern for a quilt patch is drawn on a coordinate plane where each interval represents 1 inch. So 1 inch, 2 inch, 3 inches, all that good stuff. Parallelogram ABCD represents each patch on our quilt. Now, here's the deal. Bryce is in charge of buying ribbon that will be sewn, and this feels important to me, so I'm making a little note of it, that will be sewn around the outside of each patch. So if that's the case, how many inches of ribbon are needed for each patch? You might want to find some coordinates. You might want to use some distance formula. It'll certainly help you out. So go ahead and hit pause to work this out and then hit play when you're ready to check your work. So my first thought was when I saw that around the outside, I thought, oh my gosh, you know what? We're finding the perimeter, aren't we? Right? I mean, the distance around the outside, add up all the sides, that's totally perimeter. Well, what that means, I need to find the length of each side. So the first thing I'm going to do here then is I'm going to write down all of the points. I can see that A is at 1, 1. I can see that B is at 7, -7. I can see that C is at 8, 0, and that D is at 2, 8. So I've written down all my points first. And of course, if I want to add up all the sides, I need to know how long the sides are, which means I've got to use distance formula. I got to use distance formula 4 times. So let's do it then. Let's do distance formula. Let's just start with AB. So I'm going to subtract my x coordinates, 1 minus 7, and subtract my y coordinates, 1 minus a -7. And then we're just going to work it out from here. You know that the double negative gives us a positive, and 1 minus 7 is a -6. 1 plus 7 is 8. -6 squared is 36. 8 squared is 64. I add them together, I get 100. Ooh, which is really nice. That's actually really nice. Because the square root of 100 is 10. So that made things nice and easy. Great. So I now know that the length of this side is 10. Hooray. Let's now find side BC. Let's subtract our x coordinates. 8 minus 7. We'll subtract our y coordinates. 0 minus a -7. Again, the double negative here, that becomes a big plus sign. 8 minus 7 is 1. 0 plus 7 is 7. 1 squared is 1. 7 squared is 49. And so I got the square root of 50. So this is about 7.07. And now let's do side CD. Let's do this side. I'll subtract my x's. 2 minus 8. 8 minus 0, right? You know how that works. We went too far. 2 minus 8 is, of course, a -6, and 8 minus 0 is 8. -6 squared is 36. 8 squared is 64. I'm having deja vu, are you? If I add them up, I get 100, the square root of which is 10. So yay, that's 10. And last but not least, AD. Again, I'll subtract my x coordinates, 2 minus 1. Subtract my y coordinates, 8 minus 1. 2 minus 1 is, of course, 1. 8 minus 1 is 7. 1 squared is 1. 7 squared is 49. I'm having deja vu again. 1 plus 49 is 50, and the square root of 50, we already knew earlier, is about 7.07. So about that. And of course, if we want to find the perimeter, we got to add them all up, right? 10 plus 7.07 plus 10 plus 7.07. Or I noticed 2 10s and 2 7.07. So I was like, so I'll do 2 times 10 and 2 times the square root of 50 because they each showed up twice. 2 times 10 is 20. 2 times 7.07 is 14.14. So together, I found my perimeter was about 34.14. Now, of course, this is a real world problem. If Bryce is going out to buy ribbon, is he really going to say, I need 34.14 inches of ribbon? Probably not. Maybe a little extra is not a bad thing. So Bryce went ahead and rounded up, and we're going to say that Bryce needs at least 35 inches of ribbon for each patch. That would make a lot more sense. And actually, depending on how many patches there are, it's probably going to need more than that, right? Just saying. I don't know how many patches are in the quilt. I don't know. I don't make quilts. I'll leave that to my family members. Some of them are real good at that. Let's kick this up next level, shall we? Yeah. Let's talk perimeter and area of a composite figure. And here's the deal. The method you use to determine the perimeter of a rectangle or triangle, you can actually use that with any polygon, right? If you want to find the distance around, find all the sides, right? You can use the distance formula to calculate the distance between any set of vertices and then just add the lengths of all the sides. Fine, use distance formula if you need to, and then just add up all the sides. And it doesn't matter what kind of a figure you're dealing with. Use the distance formula and add all the sides. So this means you can determine the area of what we call a composite figure by dividing the figure into a combination of rectangles and triangles. So if you have some weirdly shaped figure, so what? You know how to find the area of a rectangle. You know how to find the area of a triangle. So slice up your figure into pieces that you know, and then it's really easy to find the area. So a composite figure, this is one of your key terms, a composite figure is a figure that is formed by combining different shapes. So if you want to find the perimeter, fine, just add up all the sides, who cares what shape it is. And if you want to find the area, you might want to chop it up into pieces that you recognize. That might make it a little easier to find your area. Find the individual pieces and combine them back together again. So let's start with perimeter. Carter has an irregular backyard because it backs onto the foothill of a mountain, right? I mean, you guys know how it is. There's a lot of uneven terrain out here. It backs onto the foothill of a mountain and it's very, very rocky. The composite figure graphed on the coordinate plane, this down here, represents the usable area of Carter's backyard that is flat, right? Because there's little hilly bits and there's weird little bits, and so he can't use some of it. So each interval of the coordinate plane represents 2 yards. So please notice we are counting by twos. We're counting by twos. 2, 4, 6, 8, all that good stuff. We are counting by twos. Please watch out for that. We are counting by twos. And what I would like you to do is figure out what Carter would need here. Carter will install fencing all around the flat area of his backyard. And I would like you to determine the amount of fencing he needs to the nearest whole yard. Go ahead and hit pause, see if you can work this out, and then hit play when you're ready to check your work. So I started off with the easy sides, right? Because we said that if it's horizontal or vertical, you can just count it. So I just counted it and I was like 2, 4, 6 plus another one, that's 7. Remember, each interval is 2. So 2, 4, 6, 7, that side is 7. And then 2, 4, 6, 8, 10, 12, 14, 16, 18. Woo, that's the long side. It's probably where the house is, right? This one's not flat. I'm going to have to use distance formula. So I'm going to come back to it. I'm not ignoring GH. I'm just going to come back to it. Let's go to FG then. 1, 2, 3, 4, 5, 6. Okay. EF, also nice straight up and down. So 2, 4, 6. Easy enough. This guy right here, it looks like I go 1, 2, 3, 4. So I've only got 4 units here. CD, 2, 4, 6 units. Great. Oh, slanty one. I'm going to need distance formula, so we'll come back to that one. And then we'll look at AB. It looks like I go 2, 4, 6, 8, all the way down. So let's see if we can figure out what's going on with CB and GH because they are slanty guys. So I'm going to write down the coordinates for these, and I'm going to go ahead and use distance formula. So the coordinates for C, it looks like C is at -7. I went left 7 and up 4. And it looks like B is at 3. We went right 3 and down 2, so -2. So I'm going to go ahead and use my distance formula to help me figure this out. So subtract my x's, -7 minus 3. Subtract my y's, 4 minus a -2. Of course, the double negative becomes a positive. Negative 7 minus 3 is negative 10, and 4 plus 2 is 6. Negative 10 squared is 100, 6 squared is 36, so I have 136. So the square root of which, it looks like this side is about 11.66, something like that. Pretty close to that. Ooh, and we need to do GH as well, right? So we got to use distance formula one more time, just one more time. So I'm going to use distance formula here. Looks like for G, I went right 3 and down 8. So that's 3, negative 8. Looks like for H, we went right 10, and then we went down 12. So that's a negative 12. And again, I'm going to subtract my x coordinates, 3 minus 10, subtract my y coordinates, negative 8 minus 12, minus a negative 12, so negative 8 minus a negative 12. Of course, that becomes a plus. 3 minus 10 is a negative 7. Negative 8 plus 12 is a positive 4. Negative 7 squared is 49. 4 squared, oh my gosh, Miss Scott. 4 squared is 16, not 4. Oh my gosh, which means I need to fix a few things. So 49 plus 16, that gives me 65. Sorry about that. And of course, the square root of 65, not that, it's 8.06 roughly. Wow. See, even your math teacher makes mistakes sometimes. So 8.06, so we'll put that there. All right. I have all my sides. Let's add them all up. It's a lot of sides. So let's find our perimeter. Let's go ahead and add up all our sides. So we have 8 plus 7 plus 18. So we'll start with those. 8 plus 7 plus 18. Plus this side, which is 8.06. Plus 6 plus 6 plus 4 plus 6. Oh my gosh. Plus my last one, which is 11.66. And I'm going to bust out my calculator because I need my calculator. 8 plus 7 plus 18 plus 8.06 plus 6 plus 6 plus 4 plus 6 plus 11.66. And I got about 74.72. I did. Well, since I got 74.72, again, he's installing fencing. He's going around, and it does say yards, and it does say to round to the nearest whole yard. So it looks like we need to round that up. And we're going to say that Carter needs 75 yards of fencing. Yeah. And that should be enough to fill in the flat area on his backyard. Awesome. But now we have a new problem. Carter wants to lay grass sod in the flat area of his backyard. So he's fenced it in, but now he wants to put sod all up in there. So we need to determine the total area of sod that he needs. You know, this reminds me of what we were saying earlier, where it would probably be easier to do this if we chopped it up into pieces that we recognize, like rectangles and triangles and things like that. So how about you start by cutting it up into pieces that you can work with, rectangles and triangles and things of the like, and then find the area of each piece and then add them all back together to get the total area. I'm going to let you hit pause and work this out, and then I'll then go ahead and hit play when you're ready to check your work. Now, I'm going to cut it up, and I'll be honest, you may have cut it up differently than I did, and that's okay. You'll see. We'll talk about that in a little bit. So if you didn't cut yours up like mine, don't panic. If my cuts look a little different than yours, don't panic, okay? Just watch and we'll see what happens. So I see kind of a triangle going on here, so I chopped off that triangle. And then I was like, oh, I kind of have a square happening here. So I was like, whoop, we'll cut that off into a little square. And then I thought, well, if I cut off this bit, this would give me a rectangle and a triangle. So I cut off that bit as well. Now, again, you may have sliced yours up a little differently than mine, and that's okay. That's totally fine. We'll talk. But this is how I cut mine up. And I thought, all right, let's do this then. This is triangle CBD, right? I got triangle CBD going on here. So I'm going to go ahead and find the area. We know it's base times height. We already know this height is 6. We found it earlier. And we can find this height, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, it looks like the base of this is 10. So area of a triangle, 1/2 base times height. So I'm going to do 1/2 10 times 6. 10 times 6 is 60. Cut it in half. I get 30. Yay. Let's go ahead and find the area of our little rectangle-y, squarey looking guy here. Again, let's just figure out base times height, right? So 1, 2, 3, 4, 5, 6. It looks like I've got this side is 6. And I think we did this one earlier, right? 2, 4, 6. Yeah, we did that one earlier. So to find the area of this little guy of what we're calling EFGB, to find this guy, we're just going to do base times height. So 6 times 6, which is 36. I can manage that. I'm going to go ahead and give this guy a name. I'm going to call this I, this point I, just to make it easier to work with. And let's find rectangle AJIG or JAGI, whatever you want to call it. Jaggy, JAGI, sure. I'm going to count this base. I think it's easier. Oh, and we already found this base, right? So 1, 2, 3, 4, 5, 6, 7. So we already found that was 7. And then we'll count the length here, the height here, length times width, right? 2, 4, 6, 8, 10, 12, 14. So it looks like this side is 14 units. So to find the area of this triangle, I'm just going to do 7 times 14, which gives me 98. Thank you, Mr. Calculator. And last but not least, we have a little baby triangle down here, right? And we're going to call this triangle GHI. It's a little sideways, so I'm going to be like, that's okay, though. I'm going to call this my base, which we already know is 7, right? Because it should match this guy up here. And the height, 2, 4, looks like the height is 4. So for a triangle, 1/2 base times height. So 1/2, 7 times 4. 7 times 4 is 28. Cut it in half, and I got 14. Now, of course, this just tells me the area of each piece, right? I'm just finding the area of each piece. If I want to know the total area of the yard, you know what has to happen. I have to add these together. So 30 plus 36 plus 98 plus 14 is why I own a calculator. And I find out that the area is 178. So Carter needs at least 178 square yards of sod. Sorry, that should say we'll just get rid of the ad. So Carter needs 178 square yards of sod to cover his whole backyard that he's fenced in. Do you remember when I said earlier that you may have chopped it up a little differently, right? I mentioned that earlier, right? Can you compare the method you used to the method I used? And if you divided it differently than I did, were our answers different? And just tell me why or why not. Go ahead and hit pause, write down your thoughts on this, comparing your method to my method, and then hit play when you're ready to keep the discussion going. So hopefully, if you chopped yours up differently than I sliced up mine, you should have still gotten the same area. The total area should not have changed. Your pieces may look different, and you may have had different areas for different pieces, but when you added them all together, you should have gotten 178, just like I did. And this is because the shape of the whole figure didn't change, right? It doesn't matter how I chopped it up or how you chopped it up. The whole thing itself is still the same no matter how we divided it up. So we should have still gotten the same area. Now I've got one last little extra special bonus for you because Carter is very ambitious, right? He's working on this yard. He's gonna put a fence up. He's gonna put sod down, right? He's got a plan. He's a man with a plan and he knows what he wants to do here. What if we're told that the fencing costs $5.45 per foot and the sod costs 62 cents per square foot? Now, Carter's a little worried that he might make mistakes or that he may have measured things wrong. So Carter plans to buy an extra 10% of both materials. So how much is this going to cost Carter? Go ahead and hit pause, work this out, and then hit play when you're ready to check your work. So the first thing I did is I looked at fencing, all right, that $5.45 per foot. But I already realized a few things. First of all, we're doing an extra 10%. So here's what I'm going to do. I want that 100% of that 75 yards, but I want an extra 10% on top of it. So this is a cool math trick that always works really well. Since I'm going to get an extra 10%, I'm going to take my 75 yards and I'm going to multiply it by 110%, also known as 1.10. All right. So we're not doing 100% of the 75 yards. We're doing 110% just in case we made mistakes. Carter's a wise man. And when I multiplied 75 times 1.10, I got 82.5 yards. Now, at this point, I also realized I had another problem. This is in yards, right? This says yards. But my fencing costs $5.45 per foot. I need to do some conversions. You guys know that there's 3 feet per yard. So I took my 82.5 yards and I multiplied it by that 3 feet per yard to find that I actually have 247.5 feet. Now I can multiply by the $5.45 per foot. And I realized that just the fencing alone, please don't forget it's money, rounded 2 digits behind the decimal, it's money. I found that the fencing is going to cost me $1,348.88. Yikes. All right. That's pricey, man. I don't know. How much does it cost to build a fence these days? Well, this one gets in the materials, right? He still has to build it. Ooh, ambitious Carter. I built fences with my dad. It's work. Let's talk then about the sod. All right, let's talk about the sod. Now, again, we know we found 178 square yards earlier, but now we're saying, hey, we want 110%. So just like before, I'm going to multiply it by that 1.10. And I find that I now need 195.8 square yards. And then I realized I had another problem. Because I saw square yards and I was like, oh crap, this says 62 cents per square foot. This is a problem, but nothing impossible because we converted earlier, right? We said there were 3 feet in a yard. Ooh, but this is square yards. 3 squared would be how many are in a yard, right? 3 squared is 9. So there's actually 9 square feet per square yard. Oh, so I'm going to take this 195.8. I'm going to multiply it by 95 square feet per square yard, and that'll help me find out that it's 1,762.2 square feet. There were a lot of tricks in here, weren't there? Now we can finally do the easy part. Now I can finally just be like, fine, this 1,762.2 square feet, multiply it by my 62 cents or $0.62 per square foot. And don't forget to round to 2 digits behind the decimal because it's money. Nobody's going to cut up pieces of pennies for you. They're not. So we get $1,092.56. So this means if I add this together, because I want to know total, Carter's doing some big renovations in that backyard. That means I got to add these together for my total cost. So that means this is going to cost Carter $2,441.41 just for the materials, right? The guy's still got to build the stuff. I don't know. Maybe he can invite some friends to help him or neighbors, or he can pay them with pizza. I don't know. But at least now we know how much it's going to cost him to get all the materials to make this happen. As always, guys, I hope you found this helpful. I hope you found this useful. You got questions or concerns? Let me know. Click that Ask for Help button in the breakout room. Come see me during office hours. Do what you got to do to make this happen, man. And I'll see you guys later. Bye.